Alright, before doing something interesting, let us review some basic physics. Right? The laws of motion. The first law of motion by Newton is that if an object moves with constant speed, then the sum of all forces acting on the object is zero. So then the forces are vectors. Yeah? So the sum of all vectors is zero. Second law of motion is that the force acting on an object is acceleration times the mass. And by the way, because of this Newton's second law of motion, second order differential equations are so widely applied in physics. It's because acceleration is what is the second derivative of the position, right? So which means that if we know the force, then Newton's second law of motion, if we know how the force depends on the position, then the left-hand side of this equation is some function of the position, and the right-hand side is some function of the acceleration. And naturally, we have a second-order differential equation. So here are two specific formulas for the force. If we have the gravitational force, then the weight of an object is the gravitational force acting on it. Then we have the gravitational acceleration times mass. And Hooke's law, if we have a spring, right? So then the force needed to, to stretch a spring or to squeeze it is proportional to the displacement. And the coefficient of proportionality is called the spring constant. It is very important to keep track of units of measurement. So in all the applied physics questions, it is really crucial. So things like that, the distance is, if the distance is measured in meters, time in seconds, and mass in kilogram, then automatically the force is going to be measured in kilograms times meters over second squared, so which is a Newton. Well, a little remark. So if you want to read the textbook, so be careful, because unfortunately our textbook is published for the United States audience, and it uses non-metric system. And the funny thing about the non-metric system is what maybe very few people understand. At least I didn't know about it before 2015 when I taught this class for the first time. Right? So the funny thing is that pounds are actually not units of mass, but they are rather units of the force. Right? So when you convert pounds to kilograms, it's not really the right way to do it. Yeah, because strictly speaking, pounds, they are units of force, and units of mass in the non-metric system is pounds times second squared over feet. So that's a funny thing here. So when you try to solve, or even just to read exercises from the textbook, if you want to do it for your own practice, then please